Today's video, we're doing arithmetic in Java. Get straight into it. Start with line 20. Here we're going to go over some simple operations: plus, minus, divide, multiply. We created two variables, x and y. Initialized x to 44, initialized y to 2. We're going to create a variable called total, and we're going to make that equal to x minus y. So 44 minus 2 is 42, and we're going to simply print that out and show you that it does do that. So we'll run it here. It's all at the top. Minus is equal to 42. So that is how you create a variable, and you can use those other two variables and use a simple operation like minus to control that. Down below, line 27 is another example. This way is multiplication. I put plus there. I don't know why. We'll put multiply. So 44 times 2, which is 88. And we do the same thing to total. So now total should equal 88. And it sure does. You can also do addition, division, and a thing called modulus, which I'll show you how to do in just a little bit. We're going to move on to integer division. So we know that integers only hold whole numbers, so it is a problem when you divide a number and now that equals to a decimal. But I'm going to show you what I mean by that. So right here we have total equals x divided by y. So 44 divided by 2, which is a whole number. So I'll print that out. So it is 22. But what happens if we change y to 3? So the answer is 14.6, but integers only hold whole numbers, and total is an integer. So what happens is, all it does is get rid of that whole decimal. And I'll show you before I explain it more. So division equals 14, but the real answer is 14.6. So when you divide integers and a decimal is at the end, it just gets rid of the whole decimal. It doesn't like decimals, so it's just going to get rid of it. 14.6 actually rounds up to 15, but it doesn't work like that in Java or any other coding language. It just takes that whole decimal away. Next, we have a thing called modulus. It's an operator, and it is the percent sign. That's shift 5. I had to make sure. So here, what modulus does is kind of like saying what the remainder is, but you're also dividing in a way. So in this case, we have 44 and 3. So we're going to say 44 modulus 3. And 3 goes into 44, I think 14 times. And what it does, it tries to find the remainder without going over. So 3 times 14 is 42. And 3 times 15 would be 45. So, but we're trying to find the modulus of 44. So what this does, it goes 3, 3, 3, 3. And then when it gets close to 44, it goes as much as possible without going over. So the difference between 42 and 44 is 2. So the modulus of 44 divided by 44 modulus 3 will be 2. So modulus 2. And I'll show you another example so you can kind of wrap your head around it. So 44 with the modulus of 2 is going to be a little different. This should be 0 because 2 goes into 44 evenly. So modulus 0. And we can do another one. Let's say we'll do 5. And that should be 4 because it goes all the way up to 40, and then the next one it will go to 45. But it can't because it goes over 44. So I'll run it and I'll show you. Modulus 4. A little tricky, but once you kind of do a couple of examples, you kind of get the hang of it. Another thing modulus is used for is like comparing, or not comparing, but trying to figure out if a number is odd or even. It's a typical assignment that your professor gives you, or something you can kind of figure out by yourself. So right here I have a number, 42, and I created another variable, which is even or odd, which that's going to stay 2 always. And basically we're going to print out the number we're given and modulus by 2 to see if it's even or odd. If it's even, the answer will be 0, and if the number that is given is odd, the answer will be 1. So the number that's given is 42, and we'll modulus that by 2, and we'll get 0. Even or odd, 0. Now if we change the number to an odd number, like 45, we'll get 1. So basically, if it's even, you know it's going to go into it an even amount of time. So the modulus is going to be 0. The number remainder left is going to be 0. But if it's an odd number, like 45, it's going to go all the way up to 44 and have 1 remainder left. So that is something we use to kind of, with modulus, to kind of figure things out. It's used for a lot more other things, but that's one of the main things you kind of figure out. Another thing is percents. So percents, you can't just say 5%. It doesn't work like that exactly. I wish it did though. So you just kind of got to remember that like 50% is going to be 0.5. Just basic stuff, but you know, some people do need to know this. You can't just put percent. A low percent, like 2%, is 0.02. And I'll show you some proof real quick. So we create a variable called proof, and we're going to do 100 times percent, which the percent is equal to 50%. So I'll run it, and it should equal 50%, equal to 50, and we're good to go. We're going to move on to line 63, and now I'm just going to show you how the rules of PEMDAS or PEMDAS still applies. So in this case, Java does recognize what's multiplication and what's addition. It'll always do the parentheses, exponents, multiplication, division first. So in this case, it'd be 4 times 2 plus 5. We'll go down, which is 13. We'll move on next. 10 divided by 2, 5 minus 3, so it should be 2. Good there. Just a couple examples so you can wrap your head around it. In Modulus, you can treat that as multiplication or division. It's going to be the same thing. So that's going to be used before addition or subtraction. So in this case, we're going to do 4 modulus 2, which is 0, and then it's going to move left or right, just like normal. 2 plus 0 minus 1, which is 1. You can see here. Next, we're going to do parentheses. It still applies. It does recognize the parentheses. So up here, it's the same exact problem, but it's going to equal something different. So 5 plus 2 is 10. 5 plus 2. 5 plus 2 is 7 times 4, 28. Down here, 28. So as you wrap your head around that, we're going to move on to line 75. And right here, we're going to do combined assignment operators. What I mean by that is, in this example, we create a variable called balance, and we create a variable called deposit. So right now my bank account balance is 0, but I want to deposit $50. But I also want to change the balance with the deposit. So in this case, what we're going to do is we're going to say balance equals balance plus deposit. So balance would be 0 and deposit would be 50. But it also saves that balance as this equation. So it's going to be 50. You can see here it's going to be 50. And we're going to move on. So now if we do the same line of statement, we'll just copy it and paste it. It's going to be 50 plus 50, which is 100. So balance is saved as 50, and we're going to add another 50 to it. So now it's going to say balance equals 50 plus another 50, and it's going to be 100. I'll show you there. 100. So we're going to move on to line 84, and I'm going to go over what is called compound assignment operators. And it's basically the same thing as combined assignment operators, but with less lines of code. So it's going to be like plus equals, minus equals, as you can see here. And in this case, we're going to say balance plus equals deposit. And this statement is saying the exact same as this statement. So it's going to say balance plus equals balance plus deposit. Or in other words, balance equals balance plus deposit. Once again, it does the same exact thing as this line right here, but it's just fewer words and it makes it look neater. And I'll show you that. So right now balance equals 100. And so now we're going to add another balance to it, or add another deposit to it. So this should equal 150. And it does right here. Now we're going to move on to the minus compound assignment operator. So it does the same thing as the addition one, except for it subtracts it. So in this case, it's going to say balance equals balance minus deposit. So balance equals subtract 50, basically. So it should be 100. So after 150, it's going to be 100. Good there. So we're going to move to line 93, and we're going to go over the math class in Java. So math class is in the API, and if you don't know what the API is, it's the Application Programmer Interface, and it just basically has a bunch of standard library classes that do certain things for the programmer. And in this case, the math class has a bunch of behaviors or methods that can do stuff like square root to the power and a whole bunch of stuff, and I'll show you. So on line 94, we created a variable called result, which is a double, and we're going to make result equal to the power of 10 squared, basically 10 to the power of 2. So what we do is type math, and Java already recognizes it because it's always in there, and we need to call a certain behavior that the math class has. In order to do that, we call the dot operator. So we're going to type dot, and it's going to give us a bunch of behaviors, but we want to use the power function, which is called pow. And we're going to hit enter. Now we have proof, but we don't want that. We want the whole number 10 to the power of 2. So now result should equal to 100. We're going to run it. So result does equal to 100. And now below we have what we call the square root function of it. So we do the exact same thing. So we want the class math, which is an API, and we're going to call a certain behavior, and to do that we use a dot operator. And we want the square root function. So we find the square root function, we hit enter, and we are going to do the square root of 9, which is 3. So we're going to run that, and it's going to be 3.0. So the last thing I want to go over is what is urinary and binary. There are 3 of them. There's also a ternary, but there's only one of those in Java, so we're not going to go over that. So urinary and binary. Urinary is one sign. So if we did int y equals -3, this will be a urinary statement just because it has one single sign. Binary is going to be 2 signs. So in this statement where we initialize total, that's going to be a binary statement. What I mean by that is it does 2 things. It assigns with an equal sign and also subtracts. So in this case, line 27 would be a binary statement as well. It's going to assign something, but it's also going to multiply. And even with these down here, the compound assignment operators, it's also going to be a binary because there's 2 of them. Bi means 2. But in the case of result, I would say it'd be urinary because there's only one assigned, but you are using a math, but you're never using the plus or addition or anything. You're using a function. So I would say that would be urinary. It's pretty simple, but a ternary is obviously 3. So there would be 3 signs that you use. That wraps up basic arithmetic in Java, and I'll show you the focus points.